Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to show you some tricks and some tips on setting up a file system for Linux right after this. So, you probably have had a new drive that if you were using Windows or Mac OS and you're coming to Linux. You probably remember that when you put in a new drive into Windows, when you booted up the machine, it spotted the new drive and then it said, "Hey, this drive I don't recognize this. Do you want to quick format it? Do you want, what do you want to do with it?" And chances are you probably just did the quick format and it mounted it and you were good to go. You got off to the races and started using it. Same thing happens with Mac OS when you have a new drive that you put in. If it recognizes it, it'll mount it. If it doesn't recognize it, it will say, "I don't recognize this drive format. What do you want to do? Do you want to unmount it? Do you want to format it, or do you want to ignore it?" And so you can format it, and it'll take you into the disk utility, and then you can partition it out and whatever you want to do. But if it already has a file system on it, chances are you probably didn't do anything else with it. You probably went ahead and started using it, even though it wasn't ideal for the platform on which it was running. It probably was a FAT32, and that isn't ideal. Other than for even on Windows, it's not ideal. But in the Linux world, we do things a little bit different. And so, in 3 steps, I'm going to show you some things to do on how to set up your file system. Now. The first thing you need to know is where's the drive mounted. When you put it, I have this one here, which is this is a SSD that's mounted to a USB connector. So where did the system mount it? Where did it put the device? That's the first thing you got to find out. So the command to do that is lsblk, and it'll show you that these are the drives I have mounted. These are the 2 major drive numbers, and then these are the partitions, P1, P2, P3, P4, and then there's a crypto swap down there. So okay, great. So SDA might be the one I'm interested in because the other one's only 500, and I know from looking at this it says it's a 1 terabyte drive, but we need to verify that. And so how else could we do this? I can do an fdisk -L, but I need to be sudo. In fact, I'm just going to go ahead and become sudo for this entire, so I don't have to keep remembering to do it. So fdisk -L, oops. And that will list all the drives on the system. It'll start with the first one it finds, and this is the NVMe drive, which of course is the one that's connected to the motherboard. And that's a 0.5 gig, and that's a SSD 970 EVO. And then there's the partitions that are built on it. And then down here, we have SDA, and we don't have any other drives, so this must be it. Now, the disk model on this one won't show. And the reason for that is that it can't get past the USB to SATA bridge that's inside the machine. So it can't get to the hardware to see it. Now, some USB to SATA bridges work, and some of them don't allow you to see the drive spec. But in my case, it doesn't, but it is definitely not one of the ones that are mounted to the motherboard. And this machine doesn't have a SATA connector, so you have to either connect it through Thunderbolt, USB, or NVMe. So anyway, I got some information back on it. It's a 1 terabyte drive. We know that, and we also know that it's how it's formatted, and it has a disk label of GPT, but it doesn't have any partitions on it. Typically, that is the way you'll probably receive a disk. An SSD. Now, if it's a USB drive, chances are it's been formatted for FAT32, like a USB stick, or maybe even an external USB drive has probably already been formatted for you. So those may already come up, and they may already show a FAT32 that's installed. So what do we do with that? So I know this is SDA. So there's a couple of different ways that you can manage the partitions on a drive. So now this is on my local machine, not on the NUX, but I'll show you anyway. Let's see. Let's go to disk, and that's the one I want right there. This is GNOME disk, And GNOME Disk allows you to manage the partitions. So now I've got a 4.3 gigabyte block device, which that's just the crypto swap. And then I only have one device on the machine, which is also a 512 gigabyte drive. And that's internal to the machine. So I don't have any other drives here to mess with, but if I did, I could add a new disk image. I can attach one over here, and then I have some commands over here to restore, to benchmark, and you can even format it and all that stuff if you want. But I don't want to use this. Now there's also gparted. Gparted is the graphical user interface to parted. Parted is the command line utility that's used to do it. Nothing wrong with parted or gparted. They're fine. They're just a little bit harder to use, I think, than fdisk is. Now, gparted does and parted have a better understanding of drive geometry, and they're more efficient in managing spinning drives, typical hard drives that spin. I call them spinning rust. But so they have a better understanding of that, and they usually get that a little bit more fine, better tuned. But fdisk is an old tried and true. That's also one you can use. There's also KDE Partition Manager, which if you're running KDE, you'll have that. And then I think there's also one by that's a Qt part as well. And so yeah, if you want to use those, you can. They all do about the same thing. So I'm going to use fdisk today because that's the one I've always used, and I like it, and it works. I've never had any problems with it. So I'm going to do an fdisk and disk, and then I'm going to put in the device, and then I'll do the print. This should tell me some information about the drive. I didn't want to create a new disk label with DOS, but it did it anyway. Hey. All right, well, we'll just put it back. It's GPT is what I want. So I got ahead of myself there, but there's a list of commands here you can just do an M, and I'll show you all the commands. So the one I just did was an O, which created an empty DOS partition table, and I really wanted this one, GPT. So yeah, DOS is fine. You can use that for drives that you're not booting under UEFI with. But if you're using UEFI instead of a legacy BIOS, then you'll want to use GPT. Now I just make mine GPT anyway because I just like to have them all the same. I don't want to have one drive that has DOS on it, another one has GPT, and the reason for that is if I'm using one of the drives as a backup and I'm moving an image over from my operating system, I want to be able to boot from that drive if I need to. So I may not always create it as bootable, but anyway. So I need to find the command to create a new partition, and that's it right there. N. So we'll go ahead and do that. And this is partition number. I'm going to start with 1. It's going to start, this is picking that first sector based on the drive geometry of the SSD. I didn't do anything. It knows that. Now I can let it go ahead and take the whole disk and create one partition out of it, but I don't want that. I want 2 partitions. So I'm going to do 500 gig and just put in a plus 500 gig, and it'll say, okay, I'm going to replace, there's a signature here. I'm going to replace it. Then is it fine? Now if I print, I see the 1, and I know I have additional space on the drive. Now fdisk doesn't give you a nice map like gparted does. Gparted will actually show you that you have free space available still, but I can find that out. Yeah, F. So there's my free space. So I can get the same information. It's there. But I'll go ahead and do another new. This time it's going to say default number 2, and it's going to start at the position after where I was. So we'll go ahead and enter that, and we'll do a print, and you can see that these two line up. This is lining up right here. There's my end sector. There's my start sector. So yeah, it's lining up one sector down. So I have pretty close to the same size. They're about 200 megabyte difference, but that's close enough. And that's just because of the alignment based on the sector sizes that I've given it. So I'll go ahead and write this out, which is the write command, and that's it. As far as partitioning the drive, I'm done. That's step 1 completed. So the next thing is to go figure out what kind of file system I want to put on this. But before we do that, the command that we use is MakeFS. But I want to show you something that I bet you don't know about, unless you're an admin, and you probably already know that if you're an admin. I want 2 more. Let's see. So there's a table or a file, MakeFS .conf, and in there is all of these parameters that are defined. So I have some default ones, and there's some base features that get created. And this gets called in by the Makefilesystem utility, and this uses these to determine how to build the file system unless you override them. But I want to make you aware of it because there's going to be times where you're going to make some decisions on maybe I need to hold a lot of small files, and maybe I need to create more room for that. I have a funny story. This is back. I think this was back in the Windows 2000, or maybe just slightly after that when Windows Server first came out. But I was working on a project where we were creating files for the users. So we had a nightly process that we ran through. We were creating a bunch of files that when they came in the morning, they would have a bunch of stuff to work. But when the requirement, even though we didn't have that many users to start with, was to be able to create and handle 4 million users. So we had to run a test, and we had to make sure we could get to 4 million and see if we could actually do it. Well, we were running along, and all of a sudden the machine crashed. We started getting out around 4 million. It was getting pretty close, and then all of a sudden the machine crashed. And what happened? We didn't finish. And so we rebooted the machine, thinking, well, maybe it was just some glitch thing that happened, and when boot up, didn't find the file system. It was gone. And so we got a CD-ROM, we booted off it, and we started looking at the system drive, and there was nothing on it. It was completely overwritten by garbage. And what had happened is that in those days, Windows didn't bother to check if it had reached the maximum amount of disk that was stored in NTFS. It was an NTFS file system. And it just wrote right over top of itself, and it blew away the super block, the MBR partition, and then it overwrote some of the directory structure until it finally got enough of the operating system killed, and it blew itself apart. So Linux isn't like that, and neither is Windows anymore. Windows knows better than that now, but I do remember we reported that bug, and they were like, really? They didn't know they had a limit. So, but anyway, Linux doesn't do that, but Linux has a table that will fill up, and there are 2 tables that determine whether a drive is full or not. You may be going and looking at your drives according to how much space they have, but you can still get a message that says you're out of disk, even though you have plenty of drive space available, and that's the inode tables. There is a maximum number of inodes that you can have on the system, and so this table is where that is done. And how those are decisions that are made on how many inodes to create by default. So as you go through here, you'll see there's ext4, ext3, there's small, floppy, big, huge, news, and you'll see there's a different inode ratio tables in here. And I remember when we were discussing this one time on Usenet, this is one of those discussions that went on for weeks, in that we were trying to find out what would be the optimal one to use for each of these file types. And of course, everybody had an answer, and everybody was wrong, because we knew they were wrong because somebody told them they were wrong. And everybody was wrong. It didn't matter what you picked. You were wrong. You're just wrong. You're just wrong. That's just the way it is. So that's why this table is the way it is because there's a compromise. It was like, okay, well, all right, we'll set it to big, and then huge, and then small. But yeah, so that's what happened. But anyway, these are decisions in here that are based on what you know that your file system is going to store long term. So I just want to make you aware of that because there's also an encoding option at the bottom for the default encoding of UTF-8. If that's not a desired encoding mechanism, then you'll want to change that before you make your first file system. So anyway, enough of that. Let's go create one. I'm going to do a MakeFS. And now you used to always have to do it this way, but you can also, if you don't want to do it that way, you can do it this way. That's the actual command. You can actually execute the command itself directly. And then you just give it the actual partition, SDA1, so what I'm going to choose. And it'll start building an ext4. I'm also going to do the second one. Okay, so you'll notice that ext takes a little bit more time than most of them, and that's because it is creating super block backups, and it's also creating the journal. So yeah, and if you look in, if we go to mount this, so let's oh, I don't know, let's do, I don't need sudo. And let's make 3, and then we'll do, now, here we go again. Mount. Now I don't have to give it a type. So the second part, this is the second phase right here. I forgot to tell you that. This is phase 2, or the second step, which was to actually format the file system. And the third step and final is to mount it. So I can do a manual mount just to make sure everything's fine, and then I can add it to the FS table and the FS tab and make sure that it's there. I know people say F's tab. I never subscribed to that. To me, it's always been FS tab. But I'll do a mount. I don't know if it's correct or not. I'm not judging. So you have to tell it which partition and then where you want to mount it. And then I'll do 2. And we want to mount that to 3. So if all, and I didn't get any error messages here, so I'm assuming all is good, and we have the mount on those 2 drives right there. Now, if you're mounting this, now this is a USB, and they always tell you to mount the UUID and not the drive device name. And the reason for that is if you have multiple USB devices in the system, occasionally Linux will reprioritize the order of the USBs and it will shuffle them. So what used to be SDA1 might be your USB stick. So if you're on, like in this one, SDA1 is referring to the SSD. But if I put a USB stick in here, Linux may reorder it, and the next time I go to mount, I'm mounting the USB stick instead of my file system that I wanted at that place. So they always recommend that you use the UUID to mount from the FS tab. How do you find that out? Where do we go for that? You can just do a block ID. You can do a block ID on the device itself, so you don't have to look at everything. Oop. Okay, there's SDA1. There's the actual physical device, and there's SDA2. So the UUID is right here. You can also mount the partition ID, and either one of those will work. You also notice here that this is a good way to find out what file type it is. So if you've got a drive that you haven't used in a while and you're going to put it on the machine, and you're trying to go, wow, I got some stuff on here, but I need to get off, but I don't remember what file system I used to format it with. It happens to me all the time. But anyway, I'll go and do the block ID and find out which one it is. So all I need to do at this point, I'm gonna go ahead and add this. I'll just copy it. And I'll go just below that last UUID statement just to keep things neat. And this one is user2, ext4. I'm just going to do defaults. 0 and 1. And I need to go get the other one. I think I grabbed the wrong one, didn't I? Let's see. Let's see. I think no, that's right. That is right. So I need this one now. And we'll go right below that one. I could have just copied, the one above it, but that's all right. It doesn't take that long to. Now, if you had some special, options that you want to pass on to the ext4, great. I don't at this point, so I'll go ahead and mount user 2 and user 3, and then I'll do a mount all, and we'll make sure that the FS tab is working, and it is. So. There's one other thing I want to show you. There is what happens if, there's two things actually I want to show you. So how do you know how many inode tables you have left? I mean, you know that I can do so I can do this, and I can find out the number of blocks. Now I'm looking at 1K blocks. But I can find out the space available, and it'll tell me in a percentage how much is left. But where's the inode table? I don't see it. How do I know how many inodes I have left? Well, you do a df minus I, and it'll show you the number of inodes. Now, those two down there were the ext4 model, and if you go look at that and you multiply it out by the ratio times the size of the inodes, you'll find out that that is how it figured out where to put that. So right now I'm at 1%. I've only got 11 in use. Probably not going to worry about that for a while, huh? But df minus I will show you the inode tables. You can also, let's go over here to user 2 and play around for a little bit. Let me do a touch on 1, 2, 3, touch ABC, touch EFG, and then we'll do an LS on it. So that's great. If I do, I should have 3 more inode tables now in user 2. So I had 11, added 3, 14. That's what I got now. So that's right. So is there a way to find out what inode numbers those are? Yes. So I can do this, LI. And right out here is the inode table number. Remember, I had 11 as the start, so then 12, 13, 14. It's really logical. There's the 11. That's the less than found. It's really logical about how it does things. So, yeah, it's very logical. And so if you ever want to know, that's how you do it. And if you ever need to delete the file, there is a method to do that. I'll leave that to your own devices to find out. And I just gave you a hint. Find is how you do that. So if you want to delete a file by inode table, you can do that. One other thing I want to show you is this. Tune to FS, and I'm just going to run it by itself. Tune to FS. So you'll notice that when we created that, we looked at the MKE ext4 or mkefs.config. You'll notice that when we're in there, you saw a whole bunch of options that were set. Well, as it turns out, you can list those and you can change those on the fly if you need to, and this is the command you use to do that. So for this partition, oops, I forgot to tell it to list it. Still haven't quite got it. Let's try it lowercase l. There we go. Now it's happy. But you'll see here that there's if you gave it a volume name, it would show up here. You can give one to it now if you want. It shows where it was last mounted. There's the UUID again, so there's another way you can get it if you want. The magic number, I'm not going to go into that. That's too deep for today. But then you'll see some things down here like the inode count and the free blocks and your reserved and all this stuff. All of these are modifiable. So you can change stuff on your on your options, particularly these will probably be more of more interest to you than the others. Because depending upon the use case for your file system, you can tune it a little in order to get more performance out of it. That's the topic for another time. But I just wanted to make you aware of that. If you want to read up on it, there's a lot of things you can do with Tune2FS. A lot of things. Anyway, that's all I had for today. And I hope you enjoyed this. This is a little bit deeper than I went the last time when I talked on file systems. So 3 steps. I mean, it's not just pick a quick format and you're done. Linux wants you to think about things and map the right file system for the job that you have intended for it. So 3 steps. You have to partition the drive, format the drive, mount the drive. That's it. That's all I had for today. Hope you enjoyed this. Please like and subscribe. Hope to see you all again next time. Bye for now.